Hello scholars, welcome to our maths lesson today. We are going to complete lesson 12 of your Common Core Grade 2 Module 8 workbook. Let's see if you can recognize that equal parts of an identical rectangle can have different shapes. Let us start with this warm-up exercise. Remember using chips to solve? Alright, so let's use a chip model to add. Use your place value chart and the standard algorithm. Say the answer in both unit form and standard form. So we're adding 234 to 266. What is 234 plus 266? Now this is an addition. Therefore, in the chip model, we will represent all the given numbers because addition. If it is subtraction, remember it is only the whole number you represent and the subtrahend, that is one that you are removing, you just cancel out. But this is addition. So you see in my solving, I represented 234, that is 2 chips in the hundreds, 3 in the tens, 4 in the ones. And then the second number, 2 in the hundreds, 6 in the tens, and 6 in the ones. Now when I add all up in the ones place, I have 10, and that means I can compose a 10. When I compose a 10, I have 0 left in the ones place. And now when I add up all in the tens place, it's 10. 10 tens equals 100, so I compose 100. When after composing, I say a 0 left. So in the hundreds place, I now have 5. My answer is 500. Now look at the standard form. 234 plus 266 equals 500. 4 plus 6 is 10. Rather than 0, 3 plus 6, 9 plus 1, 10. Rather than use 0, and 1 plus 2 is 500. Alright, I have more for you. Complete these ones. 123 plus 189. Another one, 195 plus 235. Use chip model to complete these other examples. These other ones, they have very cheap questions. Math is fun. Please, you also complete your core fluency practice for lesson 12. Here's an application problem. Togo made 2 pizzas for himself and his 5 friends to share. He wants everyone to have an equal share of the pizza. Should he cut the pizzas into halves, thirds, or fourths? Half, that would be 2 equal parts. There are just 2 pizzas, if he cuts into 2 equal halves, he will have 4 halves out of the 2. But Togo plus 5 of his friends are 6. That means they will not have equal share. What if he shares it into fourths? Fourth will be 4 of that plus 4 of that, or the second pizza. They will not have equal shares. But look at thirds, as you see in the solving. The first one, he shared it into thirds, that is 1 over 3, and the second one thirds. Since they are 6, all of them can have thirds, 1/3 of the pizza. That's so simple to solve. You just need to understand the question. Isn't math so easy? Alright, here is a square, a whole square. I've partitioned this square for you. I use diagonal lines to divide it into halves. Or does it not make half for you? And then you agree it's half. Two halves makes what? A whole. Yes, that is true. Now there are two squares. Let's one to I have partitioned it. I partitioned it differently from the first one. Do you still think that this is also half? It is. It is. Although I shared this for now, and it looks like two rectangles, you see. It is true. They are still halves. Now, I want you to do some practicals for me. Use your gel board on one rubber band to create the biggest square possible. Work with your partner to see how many different ways you can show two halves. Use the same gel board square to show fourths. Work with your partner to find at least two ways to show your square split into fourths. And show me the last way you divided your square on your gel board. If you have the fourths, I'd like to see it in class. Now, look at problem 1 on the problem set. Partition the rectangles in two different ways to show equal shares. So, the rectangle, you have two of it. Partition them differently. Two halves, show two different ways. 3/3, do two different ways. And 4/4, do it two different ways. Let's use paper squares to show halves in two different ways. First, how can we tell if your square is the same size as your partner's? If you have a pin square, fold to make triangular halves. And if you have a black square, fold to make rectangular halves. Draw a line on the fold. Right, so this is what you have. I want you to cut each square into halves. The black one, rectangular halves. The pink one, triangular halves. This is what you have. So what do you notice about the halves we cut from each square? Do these pieces show half of the same sized square, even though they are different shapes? They do, yes. Those are halves. Now watch as I cut the triangle into fourths. I'm going to have you do this one too in class. See if the triangle half fits on top of the rectangle half to tell if they are the same or not. It's like what you do in your problem 2, lesson 12 problem set. You build the original whole square using the rectangle half and the half represented by your 4 small triangles. Draw it in the space below. That's what you do for me. Now let's use the halves of our paper squares to make new shapes. I'm going to give you some brown rectangular halves. Each partner should have a brown half and a black half. You make a different polygon out of your rectangular halves and out of your triangular halves. Now cut each equal part and move them to form a new polygon. What fraction of a whole is one part now? You'll tell me. We'll do that in class, and you also complete these on your own. Problems 3 and 4. You'll follow the instructions to be able to make the polygons, and then bring your work to class for marking. Bye.